Good day everybody. Today I'm going to present on autonomous vehicle steering using fuzzy logic controls. Fuzzy controllers. Fuzzy logic relies mainly on fuzzy sets. A fuzzy set does not have crisp, clearly defined boundaries, unlike the classical sets. The classical sets wholly exclude or include an element, while fuzzy sets are ordered pairs with varying degrees of relation between them. As you can see in the figure, we have a crisp set and a fuzzy set, and in the crisp set we have three cut-rate divisions of youth, middle and old with accurate values of exclusion and inclusion, while in the fuzzy set the boundary is rather blurred and there is no definite values and there is only a range or relation values. So moving on, fuzzy set is a classical set's expansion. If capital X represents the universe of discourse and its elements are labeled as small letter x, the fuzzy set A in capital X is characterized as a collection of ordered pairs, and it is represented in the equation A equal to x mu A of x and x exists in X, where mu A of x is the membership function of x in A. It maps each element of capital X to a membership value between 0 and 1, with 0 being the least relation and 1 being the maximum relation between two elements. The fuzzy logic toolbox contains various types of membership functions like the triangular membership function, trapezoidal membership function, and symbol quotient curve. The truth tables for fuzzy logic are as follows, and instead of cut right A or B, A and B, the fuzzy logics are usually represented as for and a minimum of A and B, for or maximum of A and B, while for not it is a subtraction from maximum. The if-then rules are fuzzy rules that are defined as conditional statements in the form of if x is A, then y is B. Here if is the antecedent and then is known as the consequent. So, based on these concepts of fuzzy logic, we have employed a fuzzy logic controller for vehicle steering in autonomous vehicles, and the reference we've used is fuzzy logic steering control of autonomous vehicles inside roundabouts. Vehicle control with fuzzy is a complex task requiring expert knowledge. So vehicle driving is a complex task requiring expert knowledge. In intelligent transport systems, fuzzy controllers effectively control autonomous vehicles to ensure smooth and safe driving. Fuzzy control is applied in autonomous vehicle to control because fuzzy logic is easier to define. To reiterate the objective of our study, we plan to design an optimal controller for autonomous driving in curved terrains. The curved terrains are S or hairpin roads that are predominantly curves, and there is very less straight roads in between the curves, and these are most commonly found in hilly or mountainous terrains. The design parameters and constraints are we are discussing the fuzzy variables. So fuzzy variables, we have the input variables and the output variables, and the input variables are the distance to the left lane boundary, distance to the right lane boundary, and the head angle, and the output variable is the steering angle. We have defined the fuzzy rules as if the distance to the left lane dl is near and the distance to the right lane is far and the head angle is to the left, then we need to make a sharp turn, so the SA is sharp right. steering angle is sharp right. Similarly, if DL is near and DR is medium and head is straight, then SA is to the right. If DL is medium, DR is medium and HA is straight, then SA is also straight. That is, there is no curve. And if DL is far and DR is near, then HA is right and the steering angle will take a sharp left. Based on the defined rules and variables, we have defined the membership functions. For the distances, the membership varies in near, medium, far, and for the angle, left, straight or right for the head angle, and for the steering angle it is sharp left, left, straight, right and sharp right. Moving on to the reference, let's summarize the reference. First, the fuzzy logic steering control of autonomous vehicles inside the roundabouts. As you can see in the figure, this is a roundabout, and in the roundabout we have entrance and exit points, and in the study we've considered 1 entry point and 3 exit points, and the image was derived from the live experiment conducted in the paper. A roundabout is a circular intersection or junction for road traffic flows. The radius of the roundabout is 13 meters. The number of entry points and exit points are limited to 4. One will be used as the entry and the other 3 are exits. The flow of traffic, the direction is considered counterclockwise, and the trajectory of the vehicle travel is determined by Bezier curve. And Bezier curve, you can see in the previous diagram, we have the entrance way, and based on this tangent line to the entrance point and the radius of the roundabout, the Bezier polynomial is used to obtain a trajectory. The study focuses on lateral control of the autonomous vehicles, and it assumes that the longitudinal control is already implemented. And this is the membership function of the vehicle control. We have simulated the work using Python software, and the membership of angular speed and steering position are simulated, and the output is obtained as in the figures. We have the angular speed here and steering position here, and also the control surface of angular speed and steering position are obtained. The fussified output is then defussified to obtain the values of steering speed, steering position and angular speed, and it is obtained, the steering position is obtained to be minus 46.25 degrees, and the negative sign indicates that the steering needs to be turned 46 degrees in the opposite direction of its current position, and the angular speed is around 9.4 units. So based on these examples of the vehicle driving in the roundabouts, a similar controller was designed for driving along bends and turning, such as the S or hairpin roads. In this design, the steering wheel are done for the corresponding design. In the design, the steering wheel position is the control variable. The input variables are DL, DR, HA, and output variable is the SA, and these were defined in the previous slides. The membership function of each input and output variables are defined using a triangular membership function. In the reference work, they have employed trapezoidal membership functions, but we are using triangular membership functions, and we've obtained the output as such. And this is the control surface of the steering angle, and the steering position value we've obtained around 22.49 or 22.5 degrees. Concluding, the steering angle and angular speed of an autonomous vehicle are accurately controlled through fuzzy logic controllers. The simulations were done based on the reference work. A similar controller was designed for autonomous driving along curved roads. Simulations were done and the resultant steering angle was obtained. The value was around 22.5 degrees. Thank you for listening. Thank you.